Hello, pre-calculus, 8.5 notes, super quick. It's basically simple harmonic motion. This is word problems that involve sine and cosine. Simple harmonic motion. All right, so let's just read through this. A wide variety of problems involve the harmonic motion of an object. This just means, just one motion that's going to have a pattern to it, just like sine and cosine. Okay, it's going to make that kind of a wavy motion if you were to map it out on a graph. The motion of a buoy, the up and down movement due to the wave here would be that way. You would just kind of map it though this way. Vibrations of a guitar string, basically any sound type, sound wave. A pendulum swinging back and forth, or a few examples of harmonic motion. You can take the position of a Ferris wheel and you could map it out laterally, and it would make a nice sine and cosine curve, which is harmonic motion. We're going to ignore friction and other factors, so we're not going to think about wind or anything that would mess up the repetition here. And it's almost like these problems are in a vacuum. Anyway, the movement is called simple harmonic motion, and it's modeled by sine and cosine. These are called sinusoidals, even though it's just the sine here that is sine and cosine. Sinusoidals. Okay, so we have two sinusoidals, sine and cosine. The A is for amplitude. A can be positive or negative, but the amplitude is A. Positive opens up, negative is down, goes down. D is this vertical shift. Both of those are here. C is this, B is this going to affect the period. All sinusoidals have a period of 2 pi over B. Excuse me, and so that B affects that period. And then C is going to be the phase shift once you factor B out. So this phase shift would be C over B, and it would shift left. Same thing here, when you factored B out, the phase shift would be left, opposite sign, C over B. We're going to keep these real simple, though. And we're just going to focus on the A and the B, the amplitude and the period. So the amplitude is the maximum displacement. And displacement just means distance away from the equilibrium point, or the point of equilibrium. In class, I call that the midline. That axis that the sine and the cosine kind of weave around. Period is going to be the time it takes to complete one full cycle. So if it was a Ferris wheel and you started at the bottom, how long did it take you to go all the way around and get back to the bottom? If it's a pendulum swinging back and forth, it starts left, goes right, how far till it comes back left? If it's a buoy, it going up and down, how far till it gets back up? And so then we have what's called the frequency. This is new. So you have a new little formula here. It's called the frequency. And the frequency is basically the cycles completed. Per unit of time. The good news is this formula is super easy to remember, because it's just going to be the reciprocal of the period. All right, so if I'm going to write that formula here, instead of 2 pi over B, it's just going to be B over 2 pi. Okay, and that's just the reciprocal of the period. So that's easy to remember. All right, so let's do an example. I think you have just one of these on the test. You just need to just read carefully to get this right. Sorry, I hope that wasn't too noisy. Usually the custodians don't come in when we're recording, but that's kind of loud. Anyway, buoy in a lake bobs up and down as the waves move past. So here we go. It's just bobbing up and down, and we're just going to track its movement on a lateral. Suppose the buoy moves a total of 6 feet from the high point to the low point. So 6 feet. Okay, so high point to low point, 6 feet. We're going to need to think about what that means in terms of a problem, but it's always nice to draw a little diagram. And returns to its high point every 10 seconds. Okay, So returns, that's important information. Assuming at t equal to 0, the buoy starts at a high point. So start, we're starting, this t equals to 0 is a start. That's time 0, so you have to interpret that as start. And we start at the high point and then return to the high point every 10 seconds. So that's telling you the period. So starting at the high, returning to high in 10 seconds, this is telling you the period. Okay, so the period is 10 seconds. All right, so, and then I look here and I say, assuming that at t equal to 0, we're at its high point. So which function, which sinusoidal, starts at either the high or the low, depending on if it's positive or negative, that would be cosine. So we're going to be using a cosine here. If it started at its equilibrium point, you would use sine. Okay, so the only other thing I need to get here is A, and so, you know, the high and the low points of a sinusoidal are symmetrical over this midline, or that equilibrium line, or that equilibrium point. And so this is a split of 3 and 3. You know, I don't know if this is, 4. I don't know what the high and the low point are. I don't know, if that's, 4 and 10 or whatever, but it's going to be a 3 and a 3 on either side of this midline. A distance of 6, regardless of the values of those. Okay, so that means the amplitude is 3. The amplitude is 3 here. So it's the high minus the low divided by 2. Well, I don't know what the high is. I don't know if it's 10 and 4. I don't know if it's 8 and 2. But I know when they minus, you're going to get 6, and we're going to split that from to 3 and 3. The water's just somewhere here. All right, and it's going to be amplitude is always positive, but in terms of our equation, it's going to be positive because we're starting high, and cosine starts high when it's positive cosine. All right, so we're going to write our equation. It's what we're asked to do. I put 3 positive here, cosine, and the 10 seconds does not go in front of the t as its coefficient. We have to solve for it. So 10 does not go here. We have to solve for b. And so if a period is 2 pi over b, I know my period is 10 seconds, the time it takes to complete that cycle. And then there's b. So right here, when you go to cross multiply, you're blocked by the b. So what do we do right there? We switch. And b is pi over 5. All right, so that goes right here, almost done. And then the last thing that is asked of us is to find the frequency. How many cycles are completed per unit of time? It's pretty easy to come up with this. 1 cycle per 10 seconds, right? But in case you're in a jam and you need the formula, it's just the reciprocal b over 2 pi. So the frequency is our b value of pi over 10. Sorry, pi over 5, my bad. Pi over 5 divided by 2 pi. Okay, and so to divide that, I'm going to think of 2 pi over 1, so that when I flip and multiply, I get times 1 over 2 pi, and the pi's cancel, boom, boom, and we get 1 over 10. So that should make common sense. It's completing 1 cycle, high to high, per 10 seconds. 1 cycle per 10 seconds. All right, there's a formula there, which is great if you need it, but really it's just 1 cycle per whatever the given period is. All right, folks. I guess that's it. All right, good luck, and we'll see you soon.